In order to solve this problem, we need to remember Newton's law of cooling and what each of the pieces in Newton's law of cooling represent. So Newton's law of cooling is written out there. The T of T is the final object temperature. So after a certain amount of time, what is the final temperature of the object? The T of M is the temperature of the medium or the environment that the object is in. T naught is the original temperature of the object. So before it started cooling, what was its temperature? K is going to be some constant that we have to determine, and T is going to be our variable time. Now the first thing we have to do is to plug all the information in that we had from the problem and solve for our constant K. So we know that the final object temperature was 62 degrees. We know that the temperature of the medium, or the environment, was 25 degrees. We know that the object started at 74 degrees, and we know that it cooled for 11 minutes. So we need to take all that information and plug it into our equation. Now T of 11 in this case is actually the final temperature, so that's going to equal 62. And that will equal then 25 plus 49 times e to the negative 11k. We can subtract 25 from both sides of the equation. That's going to give us 37 is equal to 49 e to the negative 11k. And we can divide both sides of the equation by 49, which will give us 0.755 is equal to e to the negative 11k. We can take the natural log of both sides, and that will allow us to get the k out as an exponent. And that'll give us the natural log of 0.755 equals the natural log of e to the negative 11k. We can then bring that exponent out front. So that's going to give us negative 0.28 is equal to negative 11k, and ln of e is just going to become 1. If we divide both sides of the equation by negative 11, we will have our k, which is 0.026. Now that we know k, we can plug that into our equation, and we can figure out how long it would take the object to cool from 74 to 30 degrees. So we're looking for a time in this situation. We know the room temperature is the same. We know the initial temperature was the same. What we're trying to figure out is if we need it to cool to 30, how long do we have to leave it there? So T of T is the final temperature that we want, so we want that to be 30. That's going to equal 25 plus, again, 49 times e raised to the negative 0.026, our k, times t. We can subtract 25 from both sides of the equation. That's going to give us 5 is equal to 49 e raised to the negative 0.026 t. And we can divide both sides of the equation by 49, which will give us 0.102 is equal to e raised to the negative 0.026 t. Again, we can take the natural log of both sides, which is going to give us the natural log of 0.102 is equal to the natural log of e to the negative 0.026t, and we can then bring that exponent out in front of the log. That's going to give us negative 2.28 is equal to negative 0.026t, and the natural log of e is just going to become 1. We can then divide both sides of our equation by negative 0.026, and that will give us our final answer, which is that it would take 88 minutes for that cooling to occur.